here we go, double angle formulas. And then we're also going to have some power reducing ones, double angle formulas. The sine of 2 theta is 2 sine theta cosine theta. Sine of 2 theta is 2 sine theta, 2 cosine theta. That's a simple one. Cosine 2 theta. Cosine squared theta minus sine squared theta. Not plus, because cosine squared plus sine squared is 1. It's not 1. It's minus on this one. However, using that identity of sine squared plus cosine squared equals 1, we can do some substitutions and rearranging and come up with a couple other formulas. 1 minus, excuse me, 2 sine squared theta, or 2 cosine squared theta minus 1. Those are alternate ones for the double angle formula. Okay. So sine squared minus cosine squared minus sine squared is the base one. The other two are ones that are derived from that. So you could use any one of those you want, and you will get the same answer. Okay, it will work out to be the same answer. And then tangent of 2 theta. You're going to love this one. It's 2 times the tangent of theta minus the tangent squared theta over minus 1 minus the tangent squared theta. It's tangent. Tangent's always more complicated than sine and cosine. We don't generally deal with secant, cosecant, and cotangent. I know that the cosecant would be 1 over this. The secant would be 1 over that. I'm not sure if the cotangent would be 1 over, would be that one flipped over. I don't think it actually is. I think the cotangent one's completely different, but generally speaking, 90% of what you deal with trig functions is sine, cosine, and tangent, with majority of what you do, particularly in real life, is sine, followed more by the tangent than the cosine. Okay, the tangent's actually used more often than the cosine is in actual applications. Now, sine is the most common, most far away, most common ones, but all of them do have applications at some point or another. So you do kind of have to be familiar with it. Okay. So find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta with the given conditions. So I'm given the sine, and I need to find the cosine of the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. And remember, the sine of 2 theta is not 2 times the sine of theta. It's 2 times the angle that I'm taking. So what I need to do is I need to figure out the other functions. I need to figure out the tangent, and I need to figure out the cosine to answer the other functions. So the first thing I'm going to do is use the information that's given and figure out the cosine and tangent. So it tells me that the sine is -4/5 and the angle is in quadrant 3. It's between pi and 3 pi over 2. That's in quadrant 3. So what I'm dealing with here is a point that's here, -4, 5. That's what the information, the sine telling me the sine is -4/5, and that it's between pi and 3 pi over 2. That means it's in the 3rd quadrant. So from there, it's actually not that hard to figure out. I've got a right triangle, solve for the missing side. It's 3, but because it's over here, bless you, it's -3. If my sine is -4/5, my cosine of theta is -3/5, and my tangent is 4/3. And those are things I'm going to need to use finding the double angles. Okay? So, just got to find the double angles. So for the sine of theta, I want to find the sine of 2 theta. It's 2 cosine theta sine theta, which means that I have 2 times the cosine, -3/5, times the sine, -4/5, and that ends up being 24/5. Sorry, 24/25. Doing the arithmetic. Now I need to find the cosine of 2 theta. Now, I have choices for which formula to use. If I was going straight to the cosine of 2 theta, and I was only given this, I would use the second one here, 1 minus 2 sine squared theta. I would do that. To be perfectly honest, the first one is actually the easiest one to do on this one, because I will have common denominators, because I have common denominators now. When I square 2 fractions with common denominators, I'll still have common denominators. It actually makes the fraction work a little easier. So I have this formula here is what I'm going to use. Cosine squared theta plus sine squared theta. So I have cosine squared plus sine, minus sine squared. Which means that I have -3/5 squared minus -4/5 squared, which means I have 9/25 minus 17/25, which means that I get -8/25. Sorry, not 17, 16. That should be 7, not 8. Minus 7, my bad. Square of the cosine minus square of the sine. And then the tangent one. Okay, the tangent one's a little nastier, just is. So the tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared theta. Tangent is 4/3. So that means I have 2 times 4/3 over 1 minus 4/3 squared. Now I'm going to work this one out for you as a reminder of how to deal with complex fractions. My numerator is 8/3. My denominator is 1 minus 16/9. So then I have 1 minus 16/9, so I still have 8/3. 1 minus 16/9 is -7/9. How do you get rid of a complex fraction? You multiply by the common denominator of the fraction in your numerator and fraction in the denominator. Common denominator between 3 and 9 is 9. So I multiply times 9, multiply times 9. That's what you do, because you want to get rid of the compound fraction. These cancel. You get -7. And then these reduce, and you multiply, and you get 24. We get negative 24/7. Yeah, it's not pretty unfair. Okay. Any questions on that one? Because really, it's picking a formula and plugging them in. Yes.
How come for the sine of 2 theta we did cosine 2 times cosine is like 2 times sine theta is
It's 2 sine cosine. I don't know why I flipped them back. Does it really matter though? I think I did it because I have a fondness for cosine over sine. Maybe. But it doesn't really matter because sine times cosine, remember, multiplication is commutative. Means you can swap them. Right? Addition and subtraction are not. You can multiply, it doesn't matter the order. Addition, subtraction, it does matter the order. Well, addition is, subtraction is not, multiplication is, division is not. No, it doesn't matter. And I don't know why I put the cosine first. It doesn't really matter. I don't know why, because in my notes I have sine before cosine. I don't know why I did that. But like I said, it doesn't make a difference. The second one does make more of a difference because you got subtraction in there, and this one it does. So let's take a look at the next problem. Now, here's the issue with this one. You got the same idea going on here. Yeah, the cosine of theta is 0.4, and we're dealing with something in the first quadrant. So I got a point somewhere in here that I'm dealing with. Problem is 0.4 by itself. Now I could, and it is doable to do it all in decimals. I could my R1 and my distance here 0.4 and then figure out my Y in decimals, but realistically, it's 2/5, right? 0.4 is 2/5. So if I'm looking for exact values, makes it easy. This is 2. This is 5. Using the Pythagorean theorem, you get the square root of 21 for your y value. So the sine is root 21 over 5. The tangent is root 21 over 2. So I do the same thing. I need to find the sine of 2 theta, which is 2 times the sine, which is root 21 over 5, times the cosine, which is 2 over 5. Which gives you 4 root 21 over 25. Now with the cosine, I have choices, and it really doesn't matter a whole lot which one I do. But I've got a radical in there, and I just don't want to mess with the radicals. If I don't have to, I don't have a choice on some of them. I don't have a choice with. I do have a choice on the cosine one, because on the cosine of 2 theta, I can use the last one that I have there, 2 cosine squared minus 1. And I can do that one, and then I won't have to deal at all with any radicals whatsoever. So it makes it a little easier for me. Does it really matter? No, in the long run, and I actually did it more than one way. So on this next one, I'm actually going to use this one here. So I'm going to 2 times the cosine 2/5 squared minus 1. 2/5 squared is 4 25ths. 2 times that is 8 25ths minus 1, which would give me negative 17 25ths. And I'm sorry, the tangent is just plain nasty. No matter how you look at it, no matter how you do it, there is no avoiding it. The tangent is just plain nasty. Okay. So the tangent of 2 theta is, so we have 2 times the tangent of theta, which is root 21 over 2, all over 1 minus root 21 over 2 squared. Well, the numerator actually isn't that bad. What do I get in my numerator? I get root 21. That's not too bad, actually, there. Root 21. In my denominator, I get 1 minus 21 over 4. And 1 is 4/4. 4/4 minus 21/4 would be negative 17/4. Yeah. I have it in my notes. I don't know what I'm figuring out in my head. So I get the square root of 21 over negative 17/4. And it's this over this whole fraction. Negative 4 root 21 over 17. So it ended up not being too nasty. Could have been a whole lot worse than it was. It's a root 21. It's a 21. It looks like a 4. It's a nasty. It's a bad looking one. Are you complaining? Are you complaining about my handwriting again? Yeah. Oh, okay. Just so we're clear. Yeah. Just so we're clear on that. And I said, oh, after 20 years, it'll get better. Questions? Okay. Power reducing formula. Ooh, sine of x squared. One minus the cosine of 2x over 2. Yes, ma'am. Oh, yes. No. Boy, there was a lot of you. I could just tell. Chills went down your spines. Okay, cosine x squared is 1 plus the cosine of 2x over 2. This is not an easy formula to remember from that standpoint of they both are almost identical, except for one is plus and one is minus, and you have to remember which one is which. So, excuse me. Sorry. So the question is, simplify the cosine squared of x over 2 minus sine squared of x over 2 using the power reducing formula. Okay. Easy enough. Plug the formula in. Take x in the formulas, replace them with x over 2. That's your first step. Cosine squared of 2x. Well, that's 1 plus the cosine of 2x all over 2. Sine squared is 1 minus the cosine of 2 times x all over 2. Or 2 times theta. 2 whatever we're taking. 2 whatever we're taking, we're cosine squared up. Yeah, so what happens there? So you get 1 plus cosine x over 2 minus 1 minus cosine x over 2. Combine them together, but here's what you want to do. Make your subtraction addition. It's actually very easy then. Change this, change these two signs. Yeah, distribute the negative. So 1 minus 1 cancels. How many cosines do we have? 2. So we have 2 cosine x over 2, which is cosine x. That's an identity. We just did an identity proof. Cosine squared of x over 2 minus sine squared x over 2 is equal to the cosine of x. That's essentially what we did, is we proved an identity here. Now, we didn't have our final goal like we normally have an identity, but that's what we did. Or I should say we created a new identity. Okay, these last ones, we're solving for theta. It's been a while since we've done this. We didn't do this since last semester. Process is the same though. So here's what we want to do. Is you want to use your identities that we've gotten the last couple of days. So the sine of 2 theta is what? 2 sine cosine. So rewrite sine of 2 theta as 2 sine theta cosine theta, and then equals cosine theta. Now, I know a number of you, a very large number of you would go, oh, divide both sides by cosine theta. No, you cannot do that. That's an illegal move. Put it all on one side. Subtract cosine theta from both sides. And you get 2 sine theta cosine theta minus cosine theta equals 0. Ooh, I heard the magic F word.
Shut up.
Factor, the 6-letter F word, factor. Factor out the cosine. Cosine theta, 2 sine theta minus 1 is equal to 0. Now, when you have two things multiplied that equal 0, that means each one of them is equal to 0. Cosine theta equals 0. 2 sine theta minus 1 is equal to 0. Okay, this one, well, I can solve that. What values between 0 and 2 pi make the cosine 0? Pi over 2 and 3 pi over 2. Straight up and down. My x is 0, straight up and down. This one I need to rearrange, add 1, divide by 2. The sine of theta equals 1/2. And where does the sine of theta equal 1/2? Pi over 6. And 5 pi over 6. Yep. Mm-hmm. Hmm? So I can factor and set each term equal to 0. Okay, number 5. What do you think the first step's going to be? Get rid of the addition formula. Okay, so that goes back to what we were doing yesterday. So the sine of theta plus pi over 2 is cosine of theta, sine theta cosine pi over 2, sine theta cosine pi over 2, plus cosine theta sine pi over 2 is equal to 1. Sorry, my bad, hang on. Plus cosine theta. Plus cosine theta is equal to 1. What is the cosine of pi over 2? 0. So that means this goes away completely because 0 times anything is 0. What is the sine of pi over 2? 1. So what I have here is I actually have the cosine of theta plus the cosine of theta equals 1. Because it equals 0. Cosine of 2 pi over 2 is 0. 0 times anything is 0. So now I have 2 cosine theta equals 1. I'm going to solve for cosine theta first. Cosine theta equals 1/2. Where is the cosine equal to 1/2? That would be pi over 3, I think. Yep, pi over 3 and 5 pi over 3. Okay. Questions? Yes. What is the sine of pi over 2? Okay. So number 6.
Yes. Can't wait to take this test, actually.
Now this one would seem a difficult one to do. I can and I can't kind of do stuff. I could do a power reducing formula of that, but when you look at the power reducing formula, it introduces something, generally speaking, introduces something nasty into your equation. It introduces 2 times the angle. So that would be introducing 2x. So it would have the cosine of 2x. I don't want to do that. I want to keep it simple. I want to have whatever I'm taking the sine or cosine of, even if that sine or cosine is squared, I still want to have this as simple as possible and have just the angle in there. In this case, just x. I want to have a cosine of x squared. I don't like having the cosine of x over 2. Yes? That's exactly what I'm thinking, what I'm kind of getting at. Because if we do that for the sine squared, we have the 4 out in front, and then the power reducing formula is 1, what is it, minus or plus? Minus cosine of 2 times x over 2 plus cosine squared x equals 2. So yeah, what happens here is because I have x over 2, 2 times x over 2 gives me what? Gives me x. So this whole thing right here just becomes cosine x. No more goofy angles. Goofy angles suck. Just say it. Goofy angles suck. So you want to just get rid of the goofy angles. Now, distribute the 4. 4 minus 2 cosine x plus cosine squared x equals 2. Because I'm distributing the 4. Or sorry, this should be 2, sorry. Because they're divided by 2. It should be the 2 in the front, not the 4. I actually made a mistake on the 4, not the 2. 2 times 4 divided by 2, right? Okay. Subtract 2 from both sides, and then rearrange it a little bit. You get cosine squared x minus 2 cosine x is equal to 0, because if I subtract 2 from both sides, that goes away, that goes away. And I have it equal to 0. Factor out a cosine. Cosine x times cosine x minus 2 is equal to 0. You have a 2 on each side. You subtract 2 from each side, what do you get?
But then what about the negative 2?
It's still there. I just moved it to, I just swapped these two to make it a little easier to work with. Factor out the cosine, 2 factors multiplied to give me 0. That means so the cosine of x is equal to 0 where? Yes. Yeah. I got it wrong in my notes. Pi over 2 and 3 pi over 2. And then I add 2 to both sides. I get the cosine of x equals 2. No, it doesn't happen. It's not in the domain. What is the maximum value of cosine? 1. What's the minimum value of cosine? Negative 1. It always goes up and down between 1 and negative 1. If you have the cosine or sine equal to something larger than 1 or smaller than negative 1, it can't happen. So if you try to take the inverse cosine of, let's say, 4, your calculator says error, which is basically saying, dummy, you can't do it for a number larger than 1. That's what error means. So this one doesn't work. So that's my answer. So I do have some valid solutions. I just only get valid solutions from one of my factors, not from both of them. And that happens sometimes. Okay, try to do number 7.
Oh, shoot, there's another one. I did not see that. You're really about to work folks.
Let's do this. Now, so, quiet please. Ladies, gentlemen, for people that were whining that didn't understand it, you're making an awful lot of noise and I'm going to explain it. Now, so I have the cosine of 2 theta. It's advisable to get the angle measurements the same side. So I have theta on one side, 2 theta on the other side. I want to get rid of the 2 theta, which means I'm going to use one of the double angle formulas. For the cosine of 2 theta, we have several choices. More than one choice will eventually give you to the same solution. Okay, now, the one I have down in my notes is the first substitution. Cosine of 2 theta is cosine squared theta minus sine squared theta equals 2 minus 2 sine squared theta. Add 2 sine squared theta to both sides. Okay, cosine squared theta. What's negative 1 plus 2? 1. So I have 1 sine squared theta is equal to 2. What is cosine squared plus sine squared? 1. So I get 1 equals 2. No solution.
Okay, you could have just changed the cosine to theta to the 1 minus exactly.
Yeah, and if you did 1 minus 2 sine theta, and you add 2 sine theta to both sides, what do you get? You still get 1 equals 2, which is no solution. So there's more than one way to do this. More than one way to do that. The correct answer is no solution. Now, quiet. If you had a problem that was no solution, you would have to write the steps to prove to me that it is no solution. Yeah, just guessing no. A WAG is not a sufficient answer.